Hi everyone. Today we are going to carry on with grade 11 physics, electrostatics, final exam revision questions and answers, number 3, lesson 3. So first of all, let's remember our rules one more time before we start our action. People, please go to video link and get questions and try. If you try, you can learn. All right. If you don't try, you cannot learn, people. People, please remember that. Please go to video link and try first, and then come back to correct your answers. So let's see what we have today. We have another 3 questions. Today we are learning calculate the electric fields. All right. So first 2 questions we are busy with forces, force between charges. Now you are gonna have 1 charge. So for these calculations, we are gonna have 1 charge. So let's remember our rules one more time, people. First of all, charge unit must be Coulomb. As you see, it is NC, but we must convert to Coulomb. Please remember that, number 1. And then number 2, force, calculating force formula. In this question, we don't need, but let's write calculation force formula is equal to calculating net force, F equals K times Q1 times Q2 over R1, 2 square. You know that. And then what we said, unit of charge always in Coulomb. If it is in Milli Coulomb, you must convert to Coulomb by 1 times 10 to the power of negative 3 coulombs. If it is micro Coulomb, every lesson I'm trying to write these units because very important. If you don't remember these units, so you are gonna get wrong answer. So please remember that. So micro Coulomb 10 to the power of negative 6. What else we have? 1 NC, just like this question. If you see NC, you are writing 1 times 10 to the power of negative 9 coulombs. And another one we didn't see so far, but PC, maybe picocoulomb, 1 times 10 to the power of negative 12 coulombs. What else we said, people? Unit of distance always in meter. If, as you see, it is centimeter, so you must convert to meter. 1 centimeter is equal to 1 over 100 meters. So 100 centimeters you can convert. When we start answering this question, we're going to convert it. Okay, this point. But as you see, they are not asking force now. And then you have only 1 charge. This one for 2 charges. If you have 2 charges, Q1 and Q2, so you can, and distance between these 2 are, and then you can use this formula, F equals K times Q1 times Q2 over R squared. But now you have only 1 charge, Q1, and there is some points, people, just they said at this point with distance. Okay, as you see, we don't have second charge. If you don't have second charge, how we are going to calculate the electric field? E equals K times Q1 over what? R squared. That's it. As you see, Q2 is gone. So if you want, you can write F equals, if this one all together E, you can write E times charge. And then we are getting unit of electric field also from here. So how can we write E from this constant, this equation? So E equals F over Q, right? And then what is unit of force? Newtons. And unit of charge is Coulomb. Newton over Coulomb is equal to your unit of electric field. But we are showing like this, Newton times Coulomb 10 to the power of negative 1. This is unit of electric field. All right. But as you see, charge always in Coulomb, and then distance always in meters. Okay. So this is our starter. So let's go to main menu. Let's go to question 1. I hope everything is fine. It is easy one. Oh, okay, I said I'm not using easy one anymore. So force equals K times Q1 times Q2 over R1, 2 square. So now our Q2 is going. What is left? K times Q1 over R square. This is our electric field formula. But important point, another important point, oh, I was forgetting that. What about direction of electric field, people? Direction of electricity. We know already for this one, if they have same charge, they repel. If they have different, they attract each other. But now what's going to happen? You don't have second charge. How they're going to repel, how they're going to attract each other. So this one, yes, for this point, if you have negative charge, okay, if you have negative charge, and then for this point, it is attracting. Okay, negative attracting. I hope it is easy. If they ask you electric field diagram, so it is coming to negative. And then if you have positive, just repel your point direction, just repel. I hope it is clear, people. If you want to draw electric field diagram, so this one just repel, you can draw this way, just going away. Okay, pushing. Just remember that. Positive, pushing. And negative, just pulling. All right. So, and then you can get direction. If you have negative, attracting. Just like you have positive here. Okay, you have just like positive Q charge here for this point. There's nothing there, but just you can think like that. If you have positive, it means you have another positive here and pushing. Repel each other, just think like that. All right. So, and then you can get direction. Positive, repel, negative, attract. Just remember that, and then you can answer, you can get correct direction. Okay, now let's continue with our question 1. Calculate electric field for 10 NC of charge at a point 100 meters away from your point. Let's continue. Our solution already here. All right. So, electric field. Let's draw our diagram first. So you don't have to draw, but to understand what's going on, if you draw, it's going to be much better. Q1, we have Q only, let's say Q1, okay. Q1 equals 10 NC. How can we convert it? 10 times 10 to the power of negative 9 coulombs. This is our first step. And then you have distance 100 meters away. You have a point here. And what is your charge, people? This one, they didn't give you direction, but we'll give you direction also. What is your charge? As you see, it is positive. What we said, positive repel. Positive repel, negative attract. So you have positive here, so repel direction to the right. So this is your electric field direction, E to the right. So this is your direction. And so this one, just to understand what's going on, right? Distance is R is equal to 100 centimeters. As you know, 100 centimeters is equal to 1 meter divided by 100, 1 meter. Or convert also already here. E is equal to K times Coulomb's constant times Q1 over R squared. So 9 times 10 to the power of 9 times 10 times 10 to the power of negative 9 is coming from Q1, and then over 1 squared. So 90 N times C times negative 1. You know how we are getting this unit also, right? Because we said force is equal to E times charge. Because force formula E is equal to here. Because Q2 is missing, we are writing Q2 just charge. And then E is equal to force over charge. It is coming from the Newton over Coulomb. And then you can write this unit N times 10 to the power of negative 1. If you need direction, so direction to the right. Or you can write east also, it's fine. Let's write to the right. Direction is going to right. I hope everything is fine. What is important point, people? Direction. Let's remember, unit of charge always in Coulomb, unit of distance always in meter. And then if you have positive charge, repel. If you have negative charge, attract. And then you are getting direction also like that. I hope everything is fine. Let's continue with next question. Let's see what they ask now. Okay, so you have first charge Q1 is equal to 6 microcoulombs, Q2 is equal to 4 microcoulombs. So distance between these two, 4 meters. All right, so calculate the net electric fields at midpoint between charges. All right, so now you have E1 and E2. All right, E1 and E2 you have. As you see, For this kind of question, sometimes they can ask you calculate force between charges. You can calculate force first, and then you can calculate electric field also. But for now, they're asking only net electric field. First of all, this point will have electric field, first electric field from Q1, let's say E1. What is direction of E1 on point A? It's not point, okay, let's make point here. E1 to the right, because what we know about E1, if it is positive, repel, we said, right? So Q1 just repel with electric field, E1 to the right. What about E2? To the left, because also repel, Q2 repel this point, and then direction of E2. From now, we are going to calculate E1 and E2 by using formula K times Q1 over R square, and then let's see our solution. Now, I hope direction is fine, and then we are going to carry on with our solution. Okay, so from now, as you see, E1 to the right, because pushing, repel, so because it is positive, all right, positive repel point A, and then E2 to the left, and then you are choosing positive, negative. Mostly let's choose right side positive, but even you don't have to choose, just you can say which one is bigger first. E1 is more than E2, so E1 minus E2. If E2 is more, so you can say like that. Let's continue. Now from now we are calculating. So E1 is equal to K times Q1 over R square. So R1 you can say 9 times 10 to the power of 9, 6 times 10 to the power of negative 6, because we are converting it as microcoulomb, over 2 square. How 2? Because half of, they said midpoint. So we are using 2 for each. Let's write 2 meters for each. It is already in meters, so we don't have to convert it. 2 meters. And you are calculating 13,500 NC, but we can write N times coulombs negative 1. It's much better. Unit, please use like this, not N over C. And then next one, E2, K times Q2 over R square. So same process, 9 times 10 to the power of 9, 4 times 10 to the power of negative 6. And you are getting 9,000 N over C, N times 10 to the power of negative 1. So from now, what are we going to do? E net is equal to E1 minus E2. E1 minus E2. Why E1 first? Because E1 is more than E2. Or you are choosing positive, negative. You can use different options for this calculation. So in this solution, they said positive. Right is positive, left is negative. And then firstly, E1 minus E2. Okay, 13,500 minus. So do the calculation, even we don't have to write units. So 13,500 minus 9,000, 4,500 newtons times coulomb negative 1. What's our direction? Right. Why right? Because as you see, E1 is more than E2. Okay, we have done our question 2. I hope everything is fine so far. What's the difference from force? Force, it was with K times Q1 times Q2 over R square, but electric field, K times Q1 over R square. So we don't have second charge. Okay, we don't have second charge. Well, how we are getting direction if you don't have second charge? Positive repel, negative attract. Okay, positive repel, negative attract. Please remember that. It's very important. Maybe you remember just one of these. Positive repel. Okay, positive repel. So this is our question 2. I hope everything is fine. Let's continue with next question, last question for today. Let's clear all. Let's go to the next question. Let's see what they ask now. Okay, similar question, but with different unit of distance. Okay, calculate the net electric field and direction, they said. Yeah, because other question, they didn't ask you direction, but we just explain how we are getting direction. Now they're asking direction also. Okay, so what are we gonna do? Let's work on this question first, and then we can see our solution. I hope you have done already. I hope you have correct answer already. So Q1 making E1 electric field. It is, as you see, it is positive. What we know, positive repel. So if you just point A here, let's make point A this side, because we have direction, just arrow already there. So this is direction of E1. Why? Because positive repel. And then what's next? We are not answering for now, just we are just showing direction, units, everything. We must just work on it first. We must understand question first, all right? So E2 this way, why? Because this is also positive and repel. If pushing, just think, okay, just to Q2 pushing A. If it is pushing, of course, it's gonna go to left. So this is our E2. From now, what's another important point? Converting units from milli coulomb to coulomb. 4 times 10 to the power of -3 coulombs is also 4. So let's write here 4 times 10 to the power of -3 coulombs. What about units? We must convert to meters. 30 over 100 is equal to 0,3 meters. 20 over 100, 0,2 meters. We are going to calculate E1 and E2. And then when you get E1 and E2, how can we get E net, net electric field? E net is equal to E1 minus E2 or E2 minus E1. How we are saying that? Why we are saying that? Because which one is bigger, we don't know for now. Or you can choose positive this side, negative this side. But finally, we are going to subtract each other because they have opposite charges. Okay, let's continue with our solution now. As you see, E1 is equal to, we know already directions. You're already here, okay? E1 and E2. So E1 is equal to K times Q1 over R square. So K is Coulomb's constant, 9 times 10 to the power of 9. And Q1 is equal to 4 times 10 to the power of -3. Why -3? Because it is MC convert to, we done already in the other slide. So 4 times 10 to the power of -3 and then 0,3. As you see, these units in solution, they didn't show all details, but you must convert them. All right, please remember. From MC, NC, just Coulomb. Charge always in Coulomb. And then what's next? We are calculating E2 with same option, same steps. Only distance difference, 0,2 now. So E1 is equal to 4 times 10 to the power of 8 and times Coulomb's power of -1. This is unit of electric field. And then E2 is equal to 9 times 10 to the power of 8. And the E net is equal to E2 minus E1. Why? Because E2 is stronger than, maybe drawing, we can draw like, but it's fine because we didn't use scale. So E2 minus E1. E2 is equal to 9 times 10 to the power of 8 minus 4 times 10 to the power of 8, 5 times 10 to the power of 8 electric field to the left because E2 is more than E1. Just change it also. This E1 is here. All right, I hope everything is fine. Today we are busy with electric field. So electric field, what we have to remember for this kind of questions, people, one more time. Units, always unit of charge in coulomb, unit of distance in meter. And then how we know direction of electric field, positive repel and negative attract. So just remember these things. After that, you can get direction. When you get final answer E1, E2, subtract, but which one is first? Stronger one is first. I hope everything is fine. Today we have done also. We are gonna carry on. More questions. Next lesson. See you next lesson, people. Thanks. Have a nice day. I hope you are getting good results. I hope you are just carry on and then you are correcting your answers. Please, people, don't forget. Get all questions first. Try first and then correct your answers. Not just getting answer. Please try first. See you next lesson, people. Thank you very much.